There are many steps one must take when training and deploying a machine learning model, from preparing data to building and training the model to deploying it for inferencing. You need to be able to organize the steps so the end-to-end process is easily repeatable. This is where machine learning pipelines can help. You use machine learning pipelines to create and manage workflows that stitch together the machine learning phases. They are cyclical and iterative in nature and facilitate continuous improvement of model performance, model deployment, and making inferences over the best performing model to date. Machine learning pipelines are made up of distinct steps. Let's walk through a typical example. First, we have data preparation, where you ingest data from one or more sources, then prepare it for model training. Some examples of data preparation include normalization, transformation, validation, and featureization. The next step is model training, where you take the output of the data preparation steps and use the output to build and train your model. Some steps you might take in this phase of the pipeline are hyperparameter tuning, automatic model selection, model testing, and model validation, which is used to find the best performing model. The final phase of the machine learning pipeline includes model deployment and optionally making batch predictions. Often, data scientists, data engineers, and IT professionals need to collaborate on building robust, scalable, and reusable machine learning pipelines. The pipelines ensure you have a repeatable process when you need to retrain your models. Another important aspect of machine learning pipelines is that they are modular. Because of this, pipeline steps are reusable and can run without rerunning subsequent steps if the output of the steps haven't changed. For example, you can retrain a model without redoing costly data preparation steps if the data hasn't changed. Pipelines also allow data scientists to collaborate while working on separate areas of the machine learning workflow. This diagram shows a pipeline represented by the dashed lines forming a rectangle around the transformers and estimators. In a typical scenario, you have multiple transformer steps and have an estimator at the end that works to modify the data. This shows a high-level view of creating a pipeline for repeatable data preparation and model training. There are typically several transformers. We're just showing two as an example. The entry point of the pipeline is the data input or ingestion of the training data. The first transformer can represent data preparation steps, such as normalization and data transformation. For example, as a first step, you might convert data types so they are consistent from multiple sources, and reduce the columns to only those that you need. The output of the first transformer is a modified data frame that gets used by the subsequent steps of the pipeline. The second transformer works to modify the data frame by applying additional data preparation steps, such as validation and featureization. An example here is to take the fields from the first modified data frame that contains string data and apply one-hot encoding on them, so we have a numeric representation available to the estimator. The output of the second transformer is a new modified data frame. The last step of the pipeline is an estimator which processes the modified data frame using the selected algorithm to train the model. The final output is the trained model. As the last step of this pipeline, you might register and deploy the model to one of the available deployment compute targets.